Hi guys, and welcome to another Python programming tutorial video. And in this video we continue with the object-oriented programming in Python, and we'll be talking about inheritance. So in the last video we started the introduction to object-oriented programming in Python, and we simply created a class, and then we also learned how to create an instance of that particular class. Now we also made mention of the init function that helps you to create the class properties as well as methods. Now in this video we'll start talking about inheritance, and let's simply create a class right here so we can understand exactly what inheritance means. So in the last video we created a class called human, and we defined a magic init function, and we define this magic init function which takes in the first parameter as self, and then it also takes in f name and l name as variables, and then we set the f name. So we said self.fname. I'm just going to clear this, okay, and then we said self.fname, okay, should equals to elf name, and we also said self.lname equals lname, and then we just defined a method right here for the full name which prints out it's going to take in the parameter self, and all it does is it just prints out so all it does is it just prints out the full name. So it concatenates the first name. So this is going to simply just say my name is, and then the self.fname, first name, and self.last name, so self.l name, and close the bracket. Now, and then we created an instance of the human, okay, and we called the human man, and then we can access this property. So that's fine, we know how to do that. Now how do we create a new class that actually inherits the object, inherit the properties and methods of the human class? Now you need to visualize inheritance as a parent-child relationship, and that's exactly what it is. It's actually a parent-child relationship. So human is going to be the parent, and the new class will be the child of the parent. Now what that simply means is that if you create a new class, okay, and you call this new class boy, for instance, you just simply say human right here like this, and what this simply means is that human boy is going to inherit the properties and method of human. Okay, now we can put a pass statement here and then test this out. So let me explain to you what I mean by parent-child relationship. Now I'll just simply go to a new page and simply tell you what it is. So we have two classes, right? The first class we created was the human class, which is the first one. Now, and then we created a boy class. Okay, now this human class is going to be the parent, okay, why this boy class here is going to be the child. So how you say this is that boy class is a child of human class, okay. Now, and what you have here means that you can actually from the boy class you can access the parameters, okay, you can access the variables in this human class, and then the methods as well, okay. But that doesn't mean that boy class cannot have its own parameters and methods. So you can its own properties. So boy class can have its own properties and methods, okay, that are actually peculiar or specific to just this boy class, okay. So this is what inheritance is all about. Now let's open our Visual Studio Code and just see exactly what we're talking about. So I'm just going to go to my desktop and open Visual Studio Code. Alright, so this is Visual Studio Code, and I've gone ahead to create the human class which we saw, and I'll just create an instance of this human class, and the instance is going to be called man, okay, and man will be equal to human, okay, and I'll just give man a name, let's say John, and I will give man a first name John and a last name Thick. Okay, so I'll save this up, and once I call the method, for instance, I access the John.full name, okay, like this. You save that. Now if I run this, you'll see that the full name will be printed to console. So sorry, I have a mistake. Man equals to human, I'm giving it John, and I'm doing this. Human is not okay. Attribute error. Human object has no attribute f name. Okay, so we're seeing some errors. Okay, so this is the error. Okay, so we're doing self.name equals f name, so we need to say self.fname, okay, and then we correct this and self.lname. okay, so I'll save this up, and you see my code now it's correct. Okay, so I'm going to clear this, and then I'll just run this. So you can see it prints out my name is John Rittick, like we expect it to work. Okay, and now the next thing we want to do is create we want to create a class from the human class, right? And the class is going to be we're going to use the keyword class, okay, and we just call the class a boy class, and in the brackets we have to say human. Okay, so what we are doing here is we are telling Python to create a boy class, and the boy class is going to be a child of the human class, and the human, whereas the human class is the parent of the boy class. And over here we can just simply say pass and test this out. Now once we say pass and we're about testing it, we create a instance of the boy class. Okay, so the instance of the boy class is equal to boy, and sorry, pass, okay, is equal to boy, and we give it some parameters once again. So the parameters we'll be giving it is the boy's name is going to be Nick, okay, so Nick, and the last name, of course, expecting is going to be Nick Sam. Okay, so I'll save that, and once I save this, I will try to access like the full name method. And remember, the full name method is not in this boy class. The full name method is actually in the human class, but can we access it? Let's try it out and see. And the answer is yes, we can access the full name method. So if I go here and I click this full name, okay, and I save that, and you see that I can just come here and clear this, okay, and then can come here and clear this, and I run the program, okay, and you see my name is Nick Sam, so I can access the full name method from my boy child class. Okay, so what is happening? The boy class is inheriting the properties and method of the human class. Now the next thing we want to do is, or the next thing I want to show you is that you can actually replace pass and do your init function once again, just as we did in the human class. Okay, so you can do your init function, you can call in self, alright, and you can call in f name and l name, okay, and you have this now. But what happens when you do this is that this new init function will replace the init function in the human class. Okay, So that is what is going to happen right here. The new init function you are calling is going to replace this init function right here. But if you don't want that to happen, here is what you do. You can either reference the name, okay, like this, and then use this dot to call the init function. But another way that Python gives you to do this, which I also love, is using this super keyword, okay. So you use the super method, and the super method you call the init function, and then you just include the variable. So we have the f name, okay, and the l name. Alright, so once you do this, the second super init method you're calling here is just a reference, or you're telling Python not to discard the init method from the human class, okay. That's what you are doing right here on line 11. Now the next thing you can now do is you can even start adding some variables or some parameters to this. So I can do, for example, here I can say self.age, for instance, right, self.age, and I will make it age, okay. Now what I need to do is, it cannot find age anywhere, so I need to come over here, right, and then add age, okay. So if I save this now, you see I've added age here and it all works out fine. Now another thing you can do, I can even add one more method. So I can say for example, I can just say birth, okay, and then birth definitely is going to take self, and I will just print the age, okay, print the age. So I can do self dot f name, and then I'll say is self dot f name is then self dot age, okay. So I'm just printing the name is age years old, okay. You need to separate this with a comma right here and save this. So what am I doing here? I've created a child class which is boy, and that child class is inheriting the properties and method of the human class, and under here I'm defining the init function for the child class, but I'm still telling the child class to retain all the properties and methods of the parent class human. And over here I'm creating an instance of the child class b1, and I have boy, I have Nick, I have Sam, and it's expecting one more parameter, which is the age, which I added here. So over here I'll just give it the age, okay. So I'll say the age is 32, and I'll save this. Now if you notice, I'm still accessing b1.fullname right here. So will it work? Yes, it will, because I've told Python to retain the properties of the super, okay, of the parent class right there. So let's just run this code and see if it works or not. So I'm just going to clear that so you have space, and I'll run this code. Now we are doing b1.fullname. Remember, full name is in the human class, full name is not in the boy class, okay. But because boy is inheriting the methods of human class, it's going to work, okay. So if I hit enter, you see it still works fine. My name is Nick Sam. Now what else can we do? We can now start accessing the specific methods, okay, in the boy class. And let's just access the birth, for instance, okay, and it just has to say the name is 32 years old, and let's see if that works. So we'll just do b1 right again, and then we do dot birth, okay, like this. And if we do b1 dot birth and save this right here, if we come down here and clear this once again for space, and sorry, not call cls, and then we run this Python program, and you see Nick is 32 years old. So what have we done here, guys? We have succeeded in creating a class, creating a parent class, creating a child class that inherits from the parent class human, okay, and then we've been able to access the methods in the parent class, okay, from an instance of the child class, okay, and we've also been able to access the methods in the child class as well. Now you can also play with this by changing specific values and parameters. So let's just say we want to change the age like we did in the first time. You do that the same way. So you just say b1 dot age, okay, and you give it the new age of 45. So if we save this and then we come down here and print this out, so we want to do print b1 dot age, right, b1 dot age, and if we save this, come here and we run this, okay, you see the new age becomes 45. So that is that about inheritance. Thank you for watching this video. Please ensure to drop your comments. If you have any, drop your questions. I would make sure I reply and respond on time. And share this video, please, if you know you find it very helpful, so that other people can also have the opportunity to learn Python programming, okay. And do ensure that you subscribe and turn on your notification so that you don't miss our next video. Now in the next video we'll be talking about things like traitors, we'll be talking about scope and a whole lot of other concepts in Python programming. So thanks for watching once again. I'll see you in the next one, guys. Bye.